Welcome to Maths and Science by IITian channel. Till now, we have released around 40 lectures discussing about many problems. From this lecture onwards, I felt it is prudent to proceed. Instead of problems, we will develop the problems as we move ahead. I want to move along with the syllabus of IIT JEE and Maths Olympiad. Instead of picking up certain problems and solving them. First and foremost, we have to understand from where we can develop the problems. Problems can be developed once we have the concepts in mind. From the first lecture, I was telling about the concepts. Now, the first and foremost for mathematics is the development of the number system. If you understand what is the number system, N, W, Z, Q, R, C. N is natural numbers, W is whole numbers, Z is integers, Q is rational numbers, R is real numbers, and C is complex numbers. Complex numbers is the biggest number system. And real numbers is the subset of complex numbers. Real numbers are subset of complex numbers. In the increasing order, the number system is there. N, W, Z, Q, R, C. Rational numbers is the subset of real numbers. Rational numbers. Integers is the subset of rational numbers. Whole numbers is the subset of integers. Natural numbers is the subset of whole number. Natural number is the subset of all other higher order numbers. Whole number is subset of all the higher order numbers Z, Q, R, C. Integers is subset of Q, R, C. Q is subset of R, C. And R is the subset of complex number. The highest order of biggest number system is complex. Now, what is the meaning of all these? Let us see. One is N, that is natural numbers. From the beginning, we started counting the quantity, like if anything, if we want to purchase, we will go and ask in the supermarket, give me 1 kg. Previously it is 1 rupee, 100 rupees, 1000 rupees. That means something is quantified in a positive way. Quantity, something is quantified in a positive way without decimals is called natural number. Like, what are the examples of natural number? 1, 2, 3, 4. These are the natural numbers. And the symbol is N. Second, what is in the order? Whole numbers. Whole numbers are the numbers where 0 is added to the natural numbers. 0, 1, 2, 3, 4. This is whole number. Third, it implies, these two imply N is the subset of W. n is the subset of w. Similarly, next is, in the order you please tell me, that is z. N is the subset of W. Now, what about Z? Z is integers. Integers means negative numbers, including 0. Z is a set of integers that minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. This is called as Z. This is integer. In the number theory we have seen something is n is an integer, p is a prime number, all these things come under Z. Positive integer means above 0, negative integer means below 0. Plus and minus will be there, positive integer. Z plus is positive integer, Z minus is negative integer. Now, next one is in our series NWZQ. Q is rational numbers. Rational numbers means they are fractions. For example, tell me whether 2 by 2 comes under rational number or not. 2 by 2 is a fraction, 2 divided by 2. Hence, it is a fraction. Hence, it is a rational number. Four by 2 is a fraction, implies it is a rational number. That means all the integers, they can be expressed in the form of a rational number, p by q. P can be any integer, q can be any integer. Then q is, it is represented as q, rational number. Now you tell me, all the above n, w, z are all these are subsets of q. Next is in the system R. This is very, very important. Real numbers. You may be wondering why I have put another vertical line before R. That is the custom. Here also we have to put the vertical line. Here also we have to put the line like this. Natural numbers also we have to put the line like this. This is a custom in mathematics to write the numbers like this. Now, real numbers is the set of numbers which are sets of which are inclusive of all other numbers, including irrational. For example, before this I will go for some 4a, let me call it as irrational numbers. They don't have a symbol. Irrational numbers means they cannot be expressed in fraction and they cannot be expressed as whole numbers, integers, and they have a value like pi. Pi is 22 by 7. It has a repeated decimals. square root of 2, repeated decimals. They have repeated decimals. They will not end somewhere, so that they can be expressed as a perfect fraction or a rational number. These are all called irrational numbers. They don't have any symbol, hence I have put them separately. Now, real numbers is the combination of natural numbers, union. It's a total of natural numbers union integers union rational numbers union irrationals that means natural numbers, whole numbers, integers, including whole numbers we can say. Integers itself includes the higher the side we are going, right hand side we are going, it should look like natural numbers. N is the subset of Z. Z is the subset of Q. Q is the subset of R. This you please remember. And irrational numbers, they don't have any symbol. Then how to represent the irrational numbers? How to represent the irrational number? As a symbol. It's a combination of two symbols. Please remember this. Irrational number is a combination of two symbols. Real numbers which exclude the numbers up to rational numbers. Hence only I have put it as a 4a. Irrational numbers is equal to real number set minus rational number set. This is what is from real numbers. If you exclude the set of rational numbers, you will get the irrational numbers. This is excluding. This symbol is excluding that slash. Now, we will go to some important definition before going to the complex number of real line. How these are represented? A line is there, and here it is 0. Here it is up to minus infinity. Here it is up to plus infinity. This is the real line in which all the numbers are embedded. You just see. For example, this is 1. This is 2. This is 3. This is 4. That means it goes up to infinity. The line starts from 0, positive real numbers, it goes up to positive infinity. And negative real numbers, that goes up to negative infinity. In between 1 and 2, there is one number called root 2, 1.414. root 3, 1.732. And in between 3 and 4, there is one irrational number called pi, that is 3.1416. These 1, 2, 3 are integer, natural numbers, and whole numbers when you include 0, and integers when you include negative numbers also. Here negative, -1, -2. You remember this real line. On the real line, there will not be any gap. It extends. It's a continuous line. There will be some number between 1 and 2. There may be infinite numbers. They may not be integers. They may not be whole numbers. They can be irrational numbers. They can be rational numbers. But infinite number of numbers are there between two real numbers. Because you see, between 1 and 2, for example, you try to understand this one, it's a very important concept. Between 1 and 2, two numbers. How many numbers may be there? 1.11111111. Decimals can be infinite. 1.11111111. 01. Decimals can be. This is also there. This is different. This is different. Both are different numbers. Different real numbers, because some 0 is here. 0 is not here. Like that, there are infinite numbers between two real numbers. And those numbers may not be integers, may not be whole numbers, may not be integers, may not be natural numbers. They can be rational numbers, or they can be irrational numbers. They can be natural numbers, they can be whole numbers, they can be integers. That means a set of natural numbers, a set of whole numbers, a set of integers, a set of rational numbers forms a set of irrational numbers forms a set of real numbers. That real number line is a ordered line, and it has a no breakage at any point of time, at anywhere, and it's a continuous line continuing from minus infinity to plus infinity, and every number is defined either as a natural number, or as a whole number, or as an integer, or as a rational number, or as an irrational number. This is the continuity of this real line. Once you understood the real line, there is one drawback with the real line. It's a line. On the real line, we cannot, please important, it's very important, we cannot find the value of square root of -1. We can find square root of 1 is equal to plus or minus 1. We know plus 1 and also minus 1. But square root of -1 cannot be represented in the real line. Square root of -1 cannot be represented on the real line. Then a imaginary system is developed. That is called as, after real numbers we get complex number. That is called as complex number. Very, very important. From complex numbers only real line is invented. Rather, from complex line, if you go and take the subsets, we will ultimately reach at the natural numbers. A complex number contains square root of minus 1. Then how to represent it? It cannot be represented by a single line, because real line is a line of real numbers. Then there should be an imaginary line to represent it. For that, what we have made? This is the real line plus infinity to minus infinity, and this is the complex number. This is the axis on which complex number is imaginary axis. It is real axis. This is imaginary axis. On the imaginary axis, square root of minus 1, that is equal to I. Because it is imaginary, the first letter of the imaginary I, we have taken it as a value I. This is imaginary. Imaginary values are taken on y-axis. Real values are taken as real axis as usual. We can say a real number. Now, imaginary line is perpendicular to the real line I. Then when you combine both real and imaginary numbers, that number is called as the complex number. For example, there is one point here P. P has coordinates real number x and imaginary number y. It is y-axis, it is x-axis. Then on a complex plane, complex number cannot be represented by a single line. It should be represented both by the real number and also imaginary number. Hence, it should be represented in a plane. It is a complex plane. In a complex plane, a number pxy, a coordinate pxy is a number which has the coordinates x and y, where x is the real number, y is the imaginary number. This p can be represented as x plus I y. This is the representation of any complex number. If y is 0, then the whole number is real number. When x is equal to 0, then the number is imaginary number. And in the next lecture, with this I want to stop this lecture. I have given the brief about the number systems. We have discussed about the natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers and complex numbers. With this, once you understand the complex plane, then how to go back from the complex plane to the natural numbers, we will move. In the next class, I will be taking up the importance of the complex number and how to move back. Because logarithms, we are talking about many logarithms we have spoken about in the last 40 lectures. Logarithms, powers, everything I am going to explain in this with complex numbers. Once you got the complex numbers concept with you clearly, then dealing with real numbers, dealing with rational numbers, dealing with irrational numbers, dealing with integers, dealing with whole numbers, dealing with natural numbers will be very, very easy for you. This next few classes, few lectures, maybe next 8 to 10 lectures, that will be on the complex numbers. I want to detail you the complex numbers so that we will move from the bigger set to the lower set. Biggest set is biggest set of numbers is complex number set. We will move from C to N. We move from C to N. Let us see what happens. We will develop the system. And you please understand, don't worry of too much of words, nothing to worry about the what you call verbose, complex number, imaginary number, real complex plane, real line, all these things you don't worry. I will make everything clear to you, and if anything, any knowledge is added to you, value addition is done from my side to you for your knowledge, then please subscribe to my channel. Subscribe to my channel Maths and Science by IITian. This is going to be a very good chapter, complex numbers. You please try to put your concentration on this. Once you understand the complex numbers clearly, you can understand the subsets in a better way. Best of luck to everybody. In these complex numbers, we will be dealing with the series also, different types of series, and from the series of logarithmic series, sequences, from complex numbers, deriving the real numbers, going back to real numbers and understanding them, that will be easier. With that view, I am concentrating on these complex numbers. Whether it is in your syllabus, I think IIT JEE in syllabus it is there, but whether in mathematics Olympiad it is there or not, it is better if you understand this. Best of luck to you. Thank you for listening to me. Please subscribe to my channel Maths and Science by IITian. Please share my channel, and for the previous videos, other videos, I give the playlist link Algebra by IITian in the description. Thank you.